All right, our next presenter, Sam Hodge. So Sam
Hi.
has 2 decades of experience in media and entertainment as a technical director, CG supervisor, and as a pipeline software engineer, including 2 visual effects Oscars for Gravity and Avatar. He's been a member of ACM SIGGRAPH and the Visual Effects Society for over a decade, and is the founder of Cognet, the maker of Rotobot, an AI-based tool for rotoscoping. Most recently, he has been applying deep learning and AI to overhead imagery for the defense and civil engineering industries, and looking at how the application of applying convolutional neural networks to near infinite pixel resolutions has changed the approach on how to train and infer deep learning. He's looking at how to apply these techniques to media and entertainment. And I've got to say, that just sounds incredibly impressive, Sam. All right, over to you.
All right. I guess I'll just start straight into my presentation, which you can find here. And I need to share computer sound, share. Sorry to talk to my notes, but look, I came from an interesting background. I'll just go to the slide. So I have a background in research in terms of science, where we were messing around with DNA and RNA to make proteins. And recently, we've been seeing that that's come to the head of, solving this pandemic that we're in by coming up with a vaccine. And so I've got a theme running through my talk about how things move through technology in about a 30-year period. But right up, the problem that I've solved is the work that's been created for rotoscoping. So rotoscoping is a term used by the machine made by Max Fleischer back in 1913. And a rotoscope is actually a machine that presents a projection of a frame of film onto a surface, so the person standing in front of the rotoscope can trace around it and get a representation of the image as a drawn image. And so with digital rotoscoping, we've fast forwarded, we're up to 2020, and the problem is pretty much still the same thing. You're presented with a frame of footage and you trace around the edges of that, and you are able to use Bezier curves and you're able to use in-betweening. But basically, you're left with the problem that you've got to trace around something at the frame rate that it's at. So if you've got 24 frames a second, you've got a minute's worth of footage, you've got a lot of frames to trace around, and there's a lot of mouse clicks involved. And the problem in the visual effects domain is that you need to come up with a narrative to present an idea. And if you're shooting without a green screen, or you're shooting without a depth camera, or you're just shooting in a hurry, you come up with the issue that you might want to put something in the background, or you might want to split this up into video layers, and you want to try out an idea on a number of shots. But because the cost of rotoscoping is so expensive, that you need to make a decision earlier on in the piece before the rotoscoping's been done. And so I thought about this problem, and this is a cheesy slide that I used for a presentation where I sort of communicate to people who weren't media entertainment experts about what the job is that Rotobot does. So in this slide here, we've got a picture of our pussycat Cosmo and a picture of a computer-generated skull. And the computer-generated skull belongs behind Cosmo's butt, but it's not presented in such a way that we can just put it in there without having a video layer of Cosmo on his own to tuck the skull behind there. And, one of the things they say on film is never work with animals and children. And so if you were trying to get the perfect performance out of a cat and the skull, putting aside the fact that you'd have to do the 3D match move of the camera, you would have to also then do the rotoscoping of the furry cat's butt to be able to put the skull behind it. And so if you were to do this in a professional film environment, what you'd probably do is outsource it to somebody so they could turn around the video layer for you. And that might charge you about $200 and might take a week to turn around. And then the reality is using machine learning, you can get a pretty good substitute using Rotobot for about an hour's worth of machine time and license costs, right? And I've got an example here of me using this as such, and there's no sound with this. And so what I've done is I've walked in front of my camera phone with it balanced up against the wall on my morning walks, and it's quite obvious I need to lose some weight. And then managed to stack together these placeholder layers with temporal offset so I can actually get an impression of this sort of work. And if I was to have done this by hand, I wouldn't be able to be out shopping. I'd be sitting there rotoscoping layers. So everybody can have this capability for free, and you can download a copy of Rotobot and you can try it out. The problem is I need to be paid for my work. So at the moment, if you downloaded it for free, you're going to get a watermark kind of like that. So this is talking about deep learning, and I've created that tool which has got deep learning, but I'd like to give you just a whistle-stop tour of what deep learning means to me. So you start out with the data set, right? And the data set that Ting was talking about was the Cocoa data set, and that's got a whole heap of labeled ground truths. So in the Cocoa data set where there's a cat, you'll have the pixels labeled as a cat in a certain color. Let's just say it's purple. And then you'll have all the dogs labeled brown. And then what you can do is sit there and create a convolutional neural network model, which will connect through a whole heap of mathematical operations to connect the pixels that look like dogs and cats with the color brown in the ground truth, right? And so then we go ahead and train the neural network with making a connection of activations in the neural network to connect the ground truth with the model. And the reality is that Rotobot is just taking the fourth part of that thing, the inference, and demonstrating that to the people that are using the tool. So the reality is it's aimed at being easy to use rather than being flexible. And so it does one job pretty well. And I've got a demonstration of that. So just a little bit more about machine learning is that machine learning intuitively is about gradient descent. It's about minimizing the loss between the data set and an approximation of that data set. So you're probably wondering why I've got a picture of a bunch of strings and holes, and I'll explain that to you. So the holes here represent the data set, right? And the model is the glass rod, which is going to be fitted to the data set. So in the model of the glass rod, we've got two parameters that we're going to be optimizing. We're going to be optimizing the slope, the rate of change of the vertical axis over the horizontal axis. And we're also going to be optimizing the intersection between the y-axis and the glass rod. So if we put this in mathematical terms, that's mx plus c. So we'll just play that back and let it optimize. And so we're training the model here by pulling the pieces of string tight. And then we've got an optimal fit for that model. The thing is, with convolutional neural networks, rather than having two parameters, the m and the c, in that linear model, we'll have 2 billion parameters, right? So there's a lot more going on. And people a lot smarter than me have put together these neural networks and made it so that we can train it. And my role in Cognat is being able to deliver these 2 billion parameters to you so that you can use them in a user interface, which is easy to use. So hopefully the audio for this is going to play. If you can't hear it, then I'm sorry, I'll start it again.
Okay, so what I've got here is I've got a piece of footage which was just some PNG files in sRGB color space, and I'm going to lay down a Rotobot person node there, and that's going to go away and compute, and it's going to remove me off the background. So then if I lay down the checkerboard and then do a merge node of this over the checkerboard, then I can make the apparent transparent background. And then if I merge the person layer over that background, we can get the idea of if I was doing something differently to the background than I am to the foreground. And then I can just come along here and I'll make this big, and then I'll actually make it 100% so we can see the pixels at 1:1, and just press play and let it calculate. And I'm not doing anything at all there, that's just computing, and there's actually motion blur and there's soft edges, and that's computing me walking around in my backyard over a variety of backgrounds with a variety of textures. There's no green screen there, and that's computing a fairly good rotoscope substitute as a pixel mask in a fairly short amount of time. And so that's doing edges, and it's computing at about 0.5 frames a second. And once that's buffered in, obviously I could write it out to disk, and then it would be computing in real time. So what we'll do is just rewind those frames and just see that once it's got up to the point that it's calculated, it's just buffered in memory, and we'll just play back in real time. So that's kind of it. That's how Rotobot Person works. There's a couple of things that are going on underneath the hood there that's been trained on sRGB images, which is in the data space color space, which is in sRGB, and it's running through that as what's called a semantic segmentation. So I've trained a whole heap of a model to say what is person and what's not person, and the results only as good as the training data. And then I've got another model in there which is going to put the soft edge on things, which is the alpha matting thing. And so in normal Rotobot, not Rotobot Person, you have to lay this down as two nodes. So initially calculate the image and then create a fringe area where the edge is, and then have it an estimate of where the edges are, and then you can get the final result. So this is actually computing live. I could bring up a window to show the NVIDIA SMI and see that there's a load. Let's just do that now. And we can see that there's a load on one of the graphics cards, and we can see that it's computing away there. And so if we rewind back to here where it's already calculated, that'll play back. We can see that there's not really too much temporal flickering there, which is the criticism that you see of semantic masks. So anyway, I'm going to leave it there. Thanks for listening, and that's our live demo.
Oops. Okay, so that was a live demonstration of the technology. I wasn't actually going to risk opening up a package on a different operating system while telecasting live with having, I don't know, 250 people in my study or whatever it is. It's interesting to see how technology has matured. So like in the 1990s, I was one of the first few people with access to the internet while working as an academic in a molecular biology lab. And nowadays in the 2020s, we can't imagine living life without the internet. In fact, people have an emotional response when the internet in their house or on their phone is out. We're also seeing in another field with something that's going to bring about an emotional response is vaccines. You know, like back in the 1990s, while I was working as a scientist, I was sequencing DNA by hand. And in about a month, I could get through about 300 base pairs. I was working for a woman called Michelle Walker. She was pregnant at the time, couldn't deal with radioactive isotopes. And so I was doing the DNA sequencing for her and get through about 300 base pairs. Now we're talking about doing exon sequencing of the human genome. So sequencing about 3.2 million base pairs, and that's done routinely, and you can have that done for you by a machine. So the concept of machines doing stuff for you is not new. It's something that's happened in my lifetime, and my job of sequencing DNA by hand is completely replaced by a machine. So when we think about that, what will be the impact of deep learning? So if you think about the substrate of computer graphics, it's basically geometry and shaders and motion, right? So when I was a lot younger than I am now, and back in 1995, I came across a wonderful package called Persistence of Vision Ray Tracing. And I could get this, and I could get the source code, and I could compile it together and produce a little animation like this. Now, that's great if you can compile ANSI C code and you have access to a Linux machine or a Unix machine as it was back then, probably HP Unix. And so the progression from there was coming up with something to work in two ways, and that's to commoditize the technology. And so if we're talking about digital characters, we've come up with something like Curious Labs Poser, where we get this sort of Smurfy looking interface, and we can sort of adjust things and come up with a human person. And then we've also got the other side of the approach with the big end of town, roughly about the same sort of time. You'd have, I think it was Sony that produced Hollow Man, and they're producing humans of this sort of quality where it looks photorealistic. So we've got things going in sort of two directions at the one time. We've got people that understand the ins and outs of shading and creating geometry. And then we've got people being able to make a consumer product where everybody can sort of eat from the same table and commoditize it. And then fast forward a long period of time, and then we found that the off-the-shelf tools are now delivering results like this, which is some work that I taught in an evening class earlier this year, where you're getting people with virtually no experience in computer graphics. They're able to produce completely photorealistic results using complete off-the-shelf tools and being guided by a Sherpa like myself, where you can produce these sort of results. And I've actually done a similar thing with a bunch of people in the legal profession producing a deepfake. And I can't really share you the deepfake that I did with them because it sort of belongs to them, but I was able to Sherpa them through the process with the tools that are available for deep learning. And the thing is, the deep learning tools are full of jaggy edges at the moment. It's not a smooth experience. You do need to get in there with the code, and it's going to take time. It's going to take time to sort of meet the market where we can sort of find the fine line between a complete pipeline experience like something that Doug's presented to us, and the complete off-the-shelf solution like me with Rotobot, where you just drag and drop a node. So what we're seeing here is that research and development, like the talk that was given to us about Gauguin, where the researchers at NVIDIA have come up with a certain amount to forge a path. And then we've got the commercial demand, which provides the incentive to innovate and commercialize the research and development. And then what we're going to find is that we've got to find the balance between the ease of use and the customization of experience, where we don't want, just cookie cutter examples. We want to be able to fine tune it. We want to be able to add our own data set. And there's going to be a lot of people playing in this game, and it's going to be a process of trial and error where people have sit there and think, oh yeah, I found the sweet point between the user experience and it being a cookie cutter mold and not having to know too much code. But the reality is, the closer that you get to the ones and zeros, the more control you have. But the productivity that you're going to have working at that low level is going to be such that you've got your cognitive load all tied up with the ones and zeros, rather than being focused on the narrative of being able to communicate the story. So I see one of the key unlocking fields is joining up the data science community with the media and entertainment community and building software bridges. I've noticed that when working in a custom pipeline, you know, like when I was at Weta Digital or Rising Sun Pictures, that you're often air gapped from the rest of the internet, and the data science community doesn't believe in being offline. And so a lot of the tools that you're creating are not compatible due to the fact that the runtime environment for a data science community might be in a Docker container, and the runtime environment for the media entertainment community might be in a res runtime environment where you're resolving everything so that Maya can run, or Houdini can run, or Nuke can run. And so you end up with certain impasses where the software engineering process for the data science community and the software engineering processes for the media and entertainment community are just clashing their wheels. And you're finding that things don't mesh together as well. And the data science community doesn't have understanding of where the media and entertainment work and earn their daily living. And the media and entertainment community doesn't have necessarily the best inkling for the latest research and development. And so it's about closing that loop and getting the people together. So Rotobot, just a little plug here, I'm wearing the logo on my shirt and close to my chest. Rotobot's available from cognate.com. It's an OpenFX plugin that works under Mac, Windows, and Linux. The CUDA acceleration is sort of passed for Mac OS. I'd like to come back to that if I had enough resources. It works in Flame and in Nuke and with free open source Natron and in DaVinci Resolve to limited success. And it's hardware accelerated using NVIDIA's CUDA layer and CUDNN. And that's sort of enabled things, but it's also come from a sort of place where it's abstracted sort of those things, so I don't have to be working down in the ones and zeros, that I can be working at a higher level with data sets and, you know, with narratives. So I think I'll stop my share there and you can see my face a little bit bigger. And then perhaps I can take some questions. So
let's see, Sunil, are you ready?
Yeah.
I'm happy. Let's see, I still see Sunil not on camera and muted. I'll go ahead. So first question, Sam, could Rotobot work with linear color space in the future?
Yeah, it certainly could. It's just a matter of making a data set which fits where I'd say that log color space would actually be the best, because then you get the most representation of color space out of the least amount of data. And so I think what people have been doing in the data science color community, they're, you know, working with a rough gamma of 2.2 and seeing that. But I think we could work with a wider gamut than sRGB and work with, you know, rather than working in the output display transform already being applied, that we could be working with a wide gamut. It's just one of the things that I alluded to in the intro is, you know, the fact that we're always limited by the video RAM that we've got available to us. And, you know, even harking back to that, you know, those little hearts that I made back in the 90s, that one of the things that you find when you're working at a big visual effects company is that they pull the compute resource together. And so nowadays, if I was wanting to compute a lot of things, I would make sure that the model would work in parallel and could be parallel trained. And then I could just go and buy as much compute as I needed off the cloud and let it train hard. But then I'd also want to be making use of, you know, cutting down on float precision and maybe doing a 16-bit half float or even an 8-bit integer, so that I could get the most throughput out of my training and the most throughput out of my inference. And I've found that, you know, one of the things that could overcome this is if you're working on tiles of an image and you're using a large computational resource, that you might be able to smash things out. And that's what I'm hoping to do this summer, your winter, here in Adelaide, and sort of, I hope you guys can understand me. I know my accent's pretty thick.
Come through loud and clear.
Okay, good.
Excellent.
Yeah, so yeah, I mean, I have a lot of opinions on where this is all going to end up, and I think it's going to be in a good place. I think it's really going to be in a place where people are able to tell their stories without using so much financial resources, and the stories will just get better. And that's always where I've come from.
Nice. And similarly, there's a question, Doug kind of answered it in the Q&A, but it's just super applicable to you as well. Do you see other applications of deep learning, machine learning in the world of compositing? So outside of Roto, other comp operations?
Yeah, look, I think probably one of the easiest things, which, you know, might even be able to be solved with traditional color science, is the neutral grade. So, you know, often we've got this problem that we're acquiring things from different sensors and different cameras and different lighting conditions, and we want things to be color accurate, you know, in a sort of scene linear sense. And, you know, it's not really that hard to pull out a Macbeth chart and, you know, pull out something and sort of work out where all of your shots are that are neutrally graded. So you can sit there and work in a sort of calibrated color space and then go back out to the client grade or whatever. And I think that this, you know, just talking about, you know, non-destructive grading and neutral grading with a Macbeth chart seems to be right for the picking. And I think some people out there are already onto that. I think you could use object detection to detect your Macbeth chart. You could zone in on, you know, your different colors, and then neutral grade stuff out, and then reverse that process. I think the time of having you know, a key artist sitting there neutrally grading plates for a really long time, which, you know, holds up the production process, could almost be entirely automated. That's the low-hanging fruit to me.
I'm sure the people who are pulling those grades would would appreciate it too. All right, the training data for Rotobot. You mentioned training data set in your talk, but
Yep.
Where did the data come from?
All right. The data sets are publicly available data sets, so they're available to everybody. And the models are also publicly available models. And, you know, there's stuff about that in the end user license agreement that's available. And so one of the things that I plan to do is make it so people can add their own data sets. And then, you know, this is what I've told with my entrepreneurial hat on, is, you know, making a marketplace for the data sets. Because, like, if you were to share a encrypted model which has just got a whole heap of floating point weights, you're not actually giving away any data from your secret film. You're just giving away a bunch of weights. And so that could be rented out from one person. Say somebody's got a skiing movie with lots of fir trees with snow on them, right? And they wanted to make a instant segmentation of the fir trees. They've trained all this stuff up, and they've done their deep learning stuff with their fir trees. And then they go, well, it's just like money for old rope. I could share this out there in a marketplace. And that was something that I wanted to develop, and then found that I'm too interested in the technology and not so interested in the commercialization of it. So if anybody's out there and, you know, wants to help out Rotobot with some of those commercial aspects, that'd be great. I'd love to hear from you.
That is awesome. All right. Thanks so much, Sam. Oh wait, there was one more question that just came in over chat. In terms of kind of the results and getting to, like, you know, pixel perfect results, would more time be something that would get you there? Is it a different data set? And also, like, what kind of images do you think are just like hard for the Rotobot to handle?
Yeah, look, I think the reality is a lot of the images that have been taken in sort of common consumer environments. So we're talking daylight on a low dynamic range camera in sort of street settings, and you'll find that a lot of science fiction and fantasy is shot in, you know, flashing lights and green and blues and teals and orange and all this sort of stuff. And you'll find that there's not always a very good match between these publicly available data sets and the sort of things that we use in thematic storytelling like science fiction and fantasy. And I think really what the solution to that is to continue with reinforcement learning, where people input, you know, the science fiction and fantasy and, you know, period drama and whatever, and input them as ground truths, then have it come out, and then have it come out in a human editable format where the splines would be adjustable. And then you sit there and say, well done, Rotobot, 10 out of 10, well, actually 8.5 out of 10. And here's the 10 out of 10 answer. And I'll put little red ticks and crosses on the Rotobot's output and say, go back to school, and then have it learn. But that's not available at the moment. That's vaporware. And I'd really love to have the time and the resources to get that programmed up. And then we could really close the loop with reinforcement learning.
That'd be amazing.
That would be amazing.
The data set that's constantly growing, training that keeps going. Yeah. Awesome. All right.
Yeah,
Go ahead.
So I've just noticed that there's another question there from Dimitro. I hope that's how you pronounce his name, about how do you bridge the gap between data science and VFX environments. That's had me scratching my head a lot. I think one of the simple solutions to that, and it's something that I've experienced as a pipeline TD, is sort of having an air gap sort of thing. If you've ever been into a zoo with an aviary and you've got the birds flying around in the cage and you want to go into the aviary, you open one door and you go into the little air gap thing, and then you open the next door and you go into the aviary, right? So I think that's kind of how we've got to treat the networked environment, so that we have this sort of air gap solution, so that the private data in a visual effects community doesn't get out, and that the data science information can get in. And that's entirely possible that you know, with your pip environments, you can have it coming from a local repository. So your Python software environments are coming from that air gap place, and then have things come in so that you can sort of make sure that the data privacy remains absolute, but then you're able to prefetch resources that you need from the data and science community. And then also possibly, I'm talking buzzwords here, like Docker containers are able to make an encapsulated software environment that sustains all the needs. And then you can just talk to that encapsulated software environment through a small port. And so you can have like a whole software pipeline just running on a port, and you just sit there and say, hey, Docker container, where is my rotoscoping? And it responds, here you are, here's some packets of information. And so that you don't actually have to have Maya running a data science environment. You just have Maya calling a port and responding with the machine learning within that. So I sort of see that as a real solution for it.
Cool. So communication channel between them, and scrub the data so no IP is getting leaked out.
Exactly. Yep.
Nice. All right. So thank you, Sam.